This video, we're going to take a look at adding, subtracting, and multiplying radical expressions. So radicals get very messy very quickly. So there's a lot of rules that are intertwined, and when do you simplify, when are you looking at the index, when you're looking at the radicand, like there's a lot going on with radicals. So when we are looking to add or subtract, we need like radicals. So like radicals have the same index and the same radicand. So what that is if I have the square root of 3 plus the square root of 3. Whoops, I put the 3 on the outside. Square root of 3. Square root of 3 and square root of 3, those are like terms. So what I do then is I add the coefficients in front of the square roots of 3. So this is 1 square root of 3 plus 1 square root of 3, giving me 2 square root of 3. So we're not adding the insides there. I'm not doing 3 plus 3 to get 6. It's the same thing as like if I had 2 or 3x squared plus 2x squared. X squared and x squared are like terms, so I would do the coefficients of 3 plus 2, which is 5x squared. I don't do anything with the exponents here. Those just establish the exponent, the power of the x, so I just combine the coefficients. Same concept with the radicals. So on number 1, 3 root 6 plus 4 root 6, 6 and 6, those are the same. I have the same index, they're both square roots, so I do 3 plus 4, which is 7, so I get 7 square root of 6. Done. Next one, I have 5 cube root of 4x minus the cube root of 4x. So they're both cube roots, both have 4x, so that means that they are in fact like terms. So this is 5 minus 1 cube root of 4x, so 5 minus 1 is 4. Cube root of 4x. So 4 cube root 4x. On number 3, we have the square root of 40 plus 3 times the square root of 90. Well, to start, they're not the same. They're the same index. They're both square roots, but they're not the same on the inside. They're not the same radicand. So that's 40 and 90. But let's see something happen here. 40 and 90, I can actually break that down a little bit. 40 is 4 times 10, because the square root of 4 is 2. So I'm actually able to rewrite this as 2 root 10. Right? 40 is 4 times 10. Square root of 4 is 2. So that's going to be 2. And then that 10 still on the inside. 10 is 5 times 2. Neither are perfect squares. What about 90? What can I do with 90? 90 is 9 times 10. Square root of 9 is 3. So this is 3 root 10. But I also have a 3 here, the coefficient of 3. So that means I have to multiply by another 3, because this is going to become 3 times 3 root 10 like that. So it's going to be 3 times 3. So that's really plus 9 square root of 10. Now they are like terms. Now I have the square root of 10, square root of 10. I'm going to do 2 plus 9, which is 11, square root of 10. So now we're pulling on the ability to simplify those radicals, and then they create like terms. So just because these original were not the same doesn't mean that they're not like terms, because we got to simplify that down, and it simplifies down to root 10 and root 10. And so we could add those coefficients of 2 and 9 together. Number 4, cube root of 16y minus the cube root of 54y. So still pulling on knowledge of, do you know your cubes, do you know your perfect squares, numbers to the fourth, like that kind of stuff. So 16 is 8 times 2, and the reason I'm using 8 is because the cube root of 8 is 2, so that's a perfect cube. So the cube root of 8 is 2. And then I still have that 2 on the inside from here. 8 times 2, cube root of 8 was 2. But I still have that 2. And then the y, can't do anything with the y. 54. 3 to the third was 27. 27 times 2 is 54. So 54 is 27 times 2. Cube root of 27 is 3. So 3, and then I still have that 2 left on the inside. So the square root of 2y. Sorry, cube root of 2y. It's to the third. There, index of 3. Now they are like terms. Cube root of 2y, cube root of 2y. So we just do 2 minus 3, which is negative 1. So I can rewrite this as negative cube root of 2y, or negative 1 cube root of 2y. Either answer is completely fine. We'd probably just go with this. but either answer is the same thing. So that's the base concept. That's all we're doing here. We're simplifying radicals. Hopefully it generates some sort of like term. If it doesn't, then can't really do anything. But let's just keep going through these. 20. 20 is 4 times 5. So 4 times 5. Square root of 4 is 2. So 2 root 5y. Still have that y left on the inside. Square root of 16y. This one's interesting because 16 is a perfect square with 4. 4 times 4. So a 4 is going to come out just cleanly. No constants or anything left in the inside. 4 times 2 is 8. This 2 has to be multiplied by that 4. The square root of 16 is 4. So then I have to do 4 times 2 to multiply those two values. So 4 times 2 is 8. So this is going to be minus 8 square root of y. Kind of weird. 45 is 9 times 5. Square root of 9 is 3. So 3 is coming out. Then the 5 has to stay in there, and then I still have that y on the inside, so the square root of 5y. After we do that, look what happens. I have only these like terms here. I just have that 2 square root of 5y and the 3 square root of 5y. That minus 8y is not a like term. It's the same index, yes. It has the y, but it doesn't have the 5. Both of these have 5y. The 8 doesn't. So I'm going to have to leave that as is, but I am going to combine the like terms of 2 square root of 5y plus 3 square root of 5y. 2 plus 3 is 5, so I'll get 5 square root of 5y minus 8 square root of y. Now it is simplified. Number 6, cube root of 54 plus 54. There's two things you could do here. First, you can identify that these are not like terms because they have different radical index. The indexes are different. It's cube root, this is a square root. So we know they're not like terms, but we can also simplify this down a little bit where I could rewrite 54. 54 is 27 times 2, and the reason I'm using 27 is because of the fact that the cube root of 27 is 3. So that's going to be 27 times 2. Cube root of 27 is 3. 3 cube root of 2 plus the square root of 54. 54 is 9 times 6. Square root of 9 is 3. Square root 6. So even when I break it down, nothing's really happening here. 3 cube root of 2 plus 3 square root 6. Number 7, square root of 125 minus square root of 5, and that's square root of 125 is over 2 minus square root of 5 over 3. I know we have different denominators here, but I want to just first take care of the radical portion of it, just to see what's gonna, maybe something's gonna simplify, like who knows. I would rather just deal with the radicals first and then go from there and see what would happen. So let's just tackle the radicals. Square root of 125. Let's take care of that. Square root of 125. 125 divided by 25 is 5. 25 is a perfect square. So that's 25 times 5. Square root of 25 is 5. So I'll have 5 square root of 5 all over 2 minus the square root of 5 over 3. Now I notice that I have these radicals that are the same, but the denominator is different. So I'm not able to just do 5 root 5 minus 1 root 5 because the denominator is different. The fraction rules still apply here. So I have to multiply, I have to get an LCD of 6. So I'm going to multiply this by 3, multiply this by 3, multiply this by 2, multiply this by 2. So that's going to be 15 square root of 5 over 6 minus 2 square root of 5 over 6. 15 minus 2 is 13. So now the denominators are the same. So now I'm able to just do 15 minus 2, which is 13. Square root of 5 over 6. 13 and 6 do not simplify. So 13 square root 5 over 6. So So number 8, we've got a little bit of a challenging visual here, at least. We have the cube root of 5x over 27 plus 2 times the cube root of 5x. Whenever you're in a position where you're like, I don't even know where to start. I don't even know what to do. Like on that last one, first I saw those denominators were different, so I knew like I have to get the least common denominator. But I saw this radical. I would rather knock that out first and try to rewrite that and see maybe something's going to happen that's going to make this a little bit easier. So on this one, what I would do is I would first take the cube root of 5x over the cube root of 27 just to see if maybe we'll have some help there. Because when I do that, I have the cube root of 5x over the cube root of 27 is 3 plus 2 times the cube root of 5x. I know I'm getting close to my camera there, so I'm trying to avoid that. Now I notice I have the cube root of 5x. I have the cube root of 5x here. So those are like terms, but again, different denominator. Here I have a 3, so I have to multiply this by 3. This is 1, so 1 times 3. This is going to be 3. I'm going to go up here. So that means I have the cube root of 5x over 3 plus 6 cube root of 5x over 3. Their denominators are the same, so I'm going to do 1 plus 6, which is 7, cube root of 5x all over 3. So the catch here is this, that I have the cube root of 27, which is 3, so then I got to make both denominators 3. And then we were able to combine like terms on the top. Now we're going to take a look at multiplying these radicals. So when you're multiplying, and let's say I have like square root of 3 times the square root of 2. When you're multiplying, you want to just make sure that the... I was going to say something, but I think I'm going to avoid saying that. Because there's a way to get around it. So I won't say what I was going to say. But the square root of 3 times the square root of 2, what we do here is we multiply by the square root of 6. It would just be 3 times 2, which is 6. So I would just do the square root of 3 times 2 and get the square root of 6. So we just multiply what's on the inside of the radical. So let's go ahead and just multiply this out. So square root of 2 times 4 and square root of 2 times square root of 30. But, side note here, 3 square root of 2 times 4 square root of 3, let's say. If I have 3 root 2 times, 4 root 3, I would multiply the outsides, those coefficients. 3 times 4 is 12. And then I would multiply 2 times 3 and get 6. So I'm not doing like square root of 2 times 4 to get square root of 8, because 4 isn't, there's no radical there. It's not 4 square root of 1 or anything like that. It's technically 4 square root of 1. But I don't multiply the 4 and the 2. I multiply the numbers on the outside together. So this is 1 times 4, which is going to be 4 square root of 2, plus, and then 2 times the square root of 30 is the square root of 60, because 2 times 30 is 60. And then from here, you simplify, if possible. So 60 is 4. So 60 divided by 4 is 15. So I could actually rewrite 60 as 4 times 15. Square root of 4 is 2. So this would be 4 square root of 2 plus square root of 4 is 2 square root of 15. No, it doesn't generate like terms, but we still need to do it. So 4 root 2 plus 2 root 13, or 15. Number 10, we have a binomial times a binomial, if you want to think of it like that. So you could do distributive property twice. So I'm doing square root of 3 times square root of 7, square root of 3 times 2. So I'm just doing square root of 3 times square root of 7, square root of 3 times 2. And then square root of negative square root of 5 times square root of 7, negative square root of 5 times 2, multiply everything out, or you could use FOIL if you know FOIL. Doesn't matter, you're going to get the same thing. So square root of 3 times the square root of 7 is the square root of 21, plus square root of 3 times 2 is 2 root 3, minus the square root of 35, 5 times 7, minus, because negative root 5 times 2 is 2 square root 5. Let's see if anything happens. Square root of 21 is 7 times 3. 7 is prime, 3 is prime, can't do anything. 2 root 3, can't do anything. Square root of 35, that's 5 times 7. 5 is prime, 7 is prime, can't do anything. 2 root 5, same thing. We have no like terms anywhere. So I have nothing I could do other than box it up and move on. There is no simplification. There is no combining like terms. There is nothing. Let's move on to 11. 4 root x times 3 root x. So I'm multiplying that. Doing 4 root x times square root of 3. 7 times 3 root x, and 7 times negative root 3. So we're multiplying all this out. Let's be careful here on these multiplications. So 4 square root of x times the square root of x. Think about this for a second. Let's just think about square root of x times square root of x first. So square root of x times the square root of x is x times x, which is x squared. So I have the square root of x squared, which is just x. Talked about that before. If I have the square root of 2 times the square root of 2, that's just going to be 2. Square root of 3 times the square root of 3, that's just 3 because square root of 9 is 3. So if you're multiplying the same thing together inside a radical, it's just going to become that number squared. If you're taking a square root, though, it just becomes that number. So if I have like the square root of y times the square root of y, that's just y, and so on. The pattern continues. So if I'm doing 4 root x times x, or root x, so 4 square root of x times the square root of x, that's just going to be 4x, because the square root of x times the square root of x is just x. Square root of x squared is x, as I've been talking about, so that's 4x. 4 root x times the square root of 3. So those are not the same. That's not like x times x like it was before. This is x times 3. So this is going to become 4 square root of 3x. 3 times x is 3x, so there's no clean little simplification that can be made there. You just have to multiply 3 and x, which is 3x. And then I'm going to do 7 times 3 root x. 7 isn't in a radical or anything, so I have to do 7 times 3, which is 21. Then I have that square root of x. Minus 7 times the square root of 3, so 7 square root of 3. And we do not have any like terms that are generated from there. I just have this 4x here, nothing there. Square root of 3x. I have the square root of x, not a like term. I have the square root of 3, not a like term. So there's no like terms. So that's going to be it for that one. Number 12, 2 root 3 minus 1 squared. So that is going to be 2 square root of 3 minus 1 times 2 square root of 3 minus 1. It's the same thing multiplied in itself. So it's 2 root 3 minus 1 times 2 root 3 minus 1. So that's just being squared. So that now, same thing that we've been doing. I'm going to distribute this twice, distribute that twice, or do FOIL. So let's be careful on the 2 root 3 times 2 root 3. I'll do this off to the side. 2 root 3 times 2 root 3. First of all, 2 times 2 is 4. Square root of 3 times square root of 3 is 3. Just mentioned that a couple times with all of this exercise right here. All of this right here was identifying the concept of if you're multiplying the same thing underneath the radical to itself, you just get that value back. So 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 4 times 3 is 12. So I get 12 here. 2 root 3 times negative 1 is negative 2 root 3. Negative 1 times 2 root 3 is negative 2 root 3. And negative 1 times negative 1 is positive 1. We do have some like terms. We have 12 plus 1, which is 13. Negative 2 root 3 minus 2 root 3 is minus 4 root 3. And then that's it. A couple more. So this is the square root of 5x minus 4 times the square root of 5x plus 4. Notice something here. It's the sum and difference of two terms. So there's a little bit of a shortcut you could take. But if you don't catch that, like if you're looking at that one and you're like, oh, I don't see the difference between that one and number 12, like what's the difference? That's just being squared. This is not being squared. This is the sum and difference of two terms. One's subtraction, one's addition. So there is a little bit of a shortcut you could take where you could square both terms and just subtract. But if you don't catch that, it's not like mandatory that you catch that. But if you don't, you just got to distribute twice. So you do square root of 5x times square root of 5x, which is just 5x. Because it's the same thing multiplied to itself. 5x times the square root of 5x is the square root of 25x squared. Square root of 25 is 5. Square root of x squared is x. We get 5x. So I'll show that to you a couple times. Plus 4 times the square root of 5x minus 4 times the square root of 5x minus 16. And then what ends up happening in the middle? Boom. Those cancel out. 4 minus 4 is 0. So we are left with 5x minus 16. Last one, square root of x minus 2 plus 3 squared. So we're going to have square root of x minus 2 plus 3 times the square root of x minus 2 plus 3. That's the same thing being multiplied to itself. This is not the sum and difference of two terms. It's the same thing being multiplied. So let's work through this. Distribute this. Square root of x minus 2 times the square root of x minus 2. Multiply, same thing to itself. It's going to be x minus 2. Get rid of the radical. Square root of x minus 2 times 3 is 3 square root of x minus 2 plus 3 times the square root of x minus 2 plus 9. We do have a little bit of some weird like terms that creates. Because I have this minus 2 and this plus 9 here, those need to be combined. I also have 3 square root of x minus 2. Those are like terms. So I'll have x. You could write this a couple different ways, but I'll just combine the negative 2 plus 9, which is 9 minus 2, which is 7. So x plus 7 plus 6 square root of x minus 2. And then that's all I could do there. So weird answer there, but that one's done. Yeah, a little bit of a weird catch there. All right, I think that's it. So a little bit of a tough section with some of that last couple problems there.